Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tear, and I haven't made a video on recreational math on this channel in a while, but I came up with a pretty amazing discovery just yesterday, actually. It turns out that the last 3 days until today, that is the 16th, 17th, and 18th of December this year, 2024, turned out to be three what I call special dates, and they're all three in a row. And this is a pretty surprising fact. And as a matter of fact, I think that these three dates are the only three consecutive dates with this particular property, which I'm going to explain in the whole 21st century or in any century. This kind of pattern repeats in every century as long as we stick with the Gregorian calendar and the way that we keep track of dates on kind of the American system of keeping track of dates. It's a little different in Europe, but anyway, let's just begin with it. So first, I'm going to talk about four different types of averages. So you guys are probably familiar with some of these or most of these. I think the first three of these are pretty standard. The most probably the average you guys are most familiar with is just what we usually call the mean, or specifically it's called the arithmetic mean. So this is nothing new. The arithmetic mean of two numbers x and y is just x plus y over 2, the sum divided by 2. You don't even have to have two things. You can have the arithmetic mean of as many things as you want, but in particular, we only care about two things here. So that I think you should all be familiar with. I think most of you are probably familiar with the geometric mean as well. So we say the geometric mean of two positive, they have to be positive in this case. Geometric mean of two positive numbers, x and y, positive real numbers, is a square root of x times y, just the square root of the product. You can kind of think of it as, if you take the logarithms, it's kind of like a logarithmic arithmetic mean, but I don't want to get into that. And then there's also something called the harmonic mean. I think this one is less well known as the first two, but the harmonic mean is kind of like you take the reciprocals and then you take the mean of the reciprocals and then you take the mean of the result. So you can write, there's a couple ways you can write it. On the bottom, I write here h of x, y for the harmonic mean. That's just 1 over the arithmetic mean of 1 over x and 1 over y. But that's a little complicated to write down. You can actually simplify a formula, and it turns out that h of x and y is just 2xy over x plus y. Um, and again, I think x and y can be arbitrary real numbers as long as they're not, the sum isn't equal to zero. You can never divide by zero. And then finally, there's another thing. I think I just came up with this myself. I don't know if I've never seen any papers, any math literature referring to this, but I define a fourth kind of mean, which I call the near geometric mean. And this is actually a special type of mean, and it doesn't work for unlike the first three means, which work for pretty much all pairs of real numbers or maybe positive real numbers. This one will only work for certain pairs of integers. It's a pretty restrictive mean. So it only works if x and y are both integers and the product is either one less or one more than a square, one more than a perfect square. So the way I define the near geometric mean of x and y in that case is just this number I'm calling z, such that satisfying the equation z squared equals xy plus or minus 1. So xy plus or minus 1 has to be a square. So an example of that would be the near geometric mean of 12. I give five examples, actually. Maybe I should start with some of the simpler ones. So the near geometric mean of 1 and 3 is 2, because 2 squared, that's 4. And 1 times 3 is 3. 4 is 1 more than the product. And the near geometric mean of 5 and 13 turns out to be 8. 8 squared is 64, and 5 times 13 is 65. You guys might have noticed that these are all Fibonacci numbers. Actually, it turns out that whenever you have three consecutive Fibonacci numbers, the one in the middle is always the near geometric mean of the two on the ends. So that's not an accident. You can try that with any other three Fibonacci numbers if you want. Turns out the first example also three consecutive Fibonacci numbers. So But then they don't have to be Fibonacci numbers. For instance, near geometric mean of 4 and 12 is 7 because 7 squared is 49 and 4 times 12 is 48. And final example I'm giving here is the near geometric mean of 12 and 24. And that turns out to be 17 because 17 squared is 289 and 12 times 24 is 288. So I think you get the idea. And the reason I'm calling them a near geometric mean is because it would be a geometric mean if I didn't have the plus or minus one here. And I think you can see that all you have to do is square the equation I wrote for the geometric mean. You see that the square of the geometric mean is just the product of the two numbers on the endpoints. So anyway, these are the four means we're considering here. So now I've just defined those. So now we're gonna bring this into the Gregorian calendar. So now I'm going to define something which I call special dates. And I have to be a little bit specific what I'm talking about here. So we're talking about dates in the Gregorian calendar, really just dates in any century in the Gregorian calendar. Might as well consider the 21st century, but it could be any other century if you want. But since we're living in the 21st century right now, maybe that's the best one to think about. So you can write any day in any century in the form MM/DD/YY, where MM are the two digits of the month, for instance, 01, 02 up to 12. You always have to put a zero to fill in the space there. DD is the date of the month, so that could be anywhere from 01 to 31. Of course, we know that not every month has 31 days, but you just go up to the limit in that case. And YY is the last two digits of the year. That's why this will work for any century. You might have different dates in different centuries, though. I mean, you have to worry about leap years, but basically, it's the same idea for every century, But anyway, so now I've defined a problem. I also want to say that maybe this doesn't really matter for what I'm talking about today, but I'm defining centuries as beginning in a year with 00 and ending in a year with 99. I know that there's not I don't think there's a agreed upon convention for this. I know that some people, use the convention that centuries always begin with a year ending in 01, like 2001 was considered the beginning of the 21st century, not 2000. Although, we did celebrate the year 2000 as Y2K. A lot of people thought that was the beginning of the 21st century. I prefer the convention where centuries begin with 00. The main reason I prefer that is just it turns out that it's a lot nicer in general to start counting with zero than with one. Computer scientists do this all the time. Ordinal numbers begin with zero. I don't want to get into this in too much detail, but there are a lot of very big mathematical advantages to start counting with zero, and I think it is a nicer convention to have centuries start with zero rather than one. But anyway, enough said about that. So now I'm going to talk about these different types of dates, and they all just involve the same means I was just talking about, same averages. So we say an arithmetic date is just a date where DD is the arithmetic mean of MM and YY, so the number in the middle. And this is kind of unique to the American way of writing dates. In Europe, they do it DDMMYY, which kind of makes more sense because date, month, year is more natural progression. But we do everything kind of backwards here in America, unfortunately. That's why we use month, date, year instead. But it turns out that these means work better if you use the American convention. So, I guess there's a silver lining behind every cloud, even if it's an American cloud. But enough about that. So anyway, here's some examples of some arithmetic dates. I mean, it turns out 010101, January 1st, 2001, turns out to be every kind of mean. I mean, that's pretty easy, except the nearly geometric mean. It's an arithmetic mean, a geometric mean, and a harmonic mean. As a matter of fact, as long as all three numbers are the same, like 12, 12, 12, that's another example of each of these means. I think the only kind of dates that are each of these means are dates where all three numbers are the same, it turns out. But anyway, so that's kind of a trivial example. January 1st, 2001, that's an arithmetic date. So is January 2nd, 2003. So is March 2nd, 2001. It turns out that these things are all symmetric. So, for instance, 010203 is a arithmetic date, and so is 030201. This is true for all these means. All these means are symmetric. That's just another way of saying that they don't depend on the order of the arguments. Yeah, symmetric functions of their arguments. And then some other examples are February 4th, 2006, 020406. These are pretty easy to come up with. 15, 20, 25. You can come up with as many as you want. 99, 98, 97. That's one towards the end of the century. No, actually, that one's wrong. there's no 99th month or 98th day of the month. So that one was a mistake. Sorry about that. But I actually did count how many arithmetic dates. I didn't make this mistake when I counted. And it turns out that there are exactly 336 arithmetic dates in the 21st century. And I think in any other century as well. I'm not sure about that. It might depend on whether or not it's a leap year. I don't know. And it turns out that 150 of them have already passed. There's been 150 arithmetic dates so far, and there's 186 remaining. Even though we're only one quarter of the way through the 21st century, we're almost halfway through all the arithmetic dates. It turns out that all of these dates tend to be biased towards the beginning of the century. I think the other ones even more so than the arithmetic dates, although I haven't counted how many there are of each of the other type. But anyway, let me just go through the other types. They're all based on the other types of means I've talked about. So a geometric date is just a date where DD is the geometric mean now of MM and YY. So examples of that would be, again, January 1st, 2001. But then we have January 2nd, 2004, because 2 is the geometric mean of 1 and 4. And then, of course, it's symmetric, so April 2nd, 2001 is another geometric date. So is February 4th, 2008. The 6th, no, I made another mistake here. There's no 16th month. Sorry about that. But September 27th, 2081, it will be a geometric date. That's one in the future. That one I did get right. Harmonic date. Yeah, again, I can see I made some mistakes on this one too. Harmonic date is just one where the date is the harmonic mean of the month and the year. So some examples of that again: January 1st, 2001, February 3rd, 2006, June 3rd, 2002, just because it's symmetric again. December 15th, 2020. You can check that that's a harmonic date. The next one I got wrong because there's no 20th month. And the last one's wrong too. There's no 48th month. So forget those. But I think you get the idea. And then finally, nearly geometric dates. These ones I think are the rarest. I'm not sure about this, but I gave some examples here. These are ones where the date is the near geometric mean of the month and the year. Remember, I said that this is kind of a special mean because not every combination of months and years the product has to be either one less or one more than a square. They're kind of easy to construct. Here's some examples. So it turns out that January 1st, 2000. None of these other means will work if the year is 2000, by the way, because it's 0, 0. And it turns out that you can't have a near geometric mean where one of the endpoints is 0. In this case, it has to be the year because there's no 0th month. But yeah, you have January 1st, 2000 is a nearly geometric date. And I think it's the only special date, if you call these special dates, all these different kinds of mean dates defined by these 4 different kinds of means. I think that's the only one in the year 2000, if I'm not mistaken. Maybe I'm wrong. Actually, I think there are arithmetic ones like February 1st. No, I forget what I said. There's February 1st, 2000, April 2nd, 2000. I think there's 6 of them in 2000. But then here's some other examples of nearly geometric dates. Also, January 1st, 2002, because 1 times 2 is 2. That's 1 more than 1 squared. January 2nd, 2003. These are kind of trivial examples. 1 times 3 is 3, which is 1 less than 2 squared. May 2nd, 2001. It's actually pretty easy to construct some of these, at least the ones where the numbers are small. This is an example involving Fibonacci numbers, August 13th, 2021, because there are three consecutive Fibonacci numbers. You can check yourself. 13 squares 169. 8 times 21 is 168, which is one less. And then this one, last one I gave is kind of late in the century. October 31st, Halloween 2096 turns out to be a nearly geometric date. Something you can tell your grandchildren or great great grandchildren. I don't know. Anyway, so those are some examples of some special dates. But now I'm gonna come to the climax of my talk, and now it turns out, now that I've defined all these special types of dates, I think you know what I'm talking about now. The last 3 days just turned out to all be 3 consecutive special dates. How about that? February 16th, 2024. That was a harmonic date. 16 is a harmonic mean of 12 and 24. You can check that yourself. 17 turns out to be the nearly geometric mean of 12 and 24. I think I already gave that example. That was 2 days ago. 12, 16, 24 was 3 days ago. And yesterday was an arithmetic date, 12, 18, 24. That's pretty easy to see. Just a geometric arithmetic progression where each one was 6 more than the last one. So pretty remarkable, I think. And I haven't checked this yet, but I suspect that this is the only example in the entire century. Of course, this will happen every century, but you'll have to wait another 100 years. And I don't think most of us are going to be alive in another 100 years. So, consider yourself lucky. We've had 3 consecutive special dates just in the last 3 days. And I think I'm going to just say one more thing about this. How did I discover this? I discovered this by accident. I went to the bank yesterday. I had to deposit a check, and they wanted me to write the date on the check. And I wasn't sure what date of the month it was. I thought it was the 17th. So I first wrote 12/17/24, and then the teller corrected me and told me it was the 18th. And then, I noticed right away that 12/18/24 is a geometric progression. But then I realized shortly afterwards when I came home that, wait a minute, 12/17/24, that's pretty close to a geometric progression. It's not exactly, because 17 is the exact geometric mean of 12 and 24, but it's kind of as close as it could be. And then, I also realized 12/16/24, that's a harmonic progression. How about that? I thought, how cool is that? So anyway, that concludes my video for today. Thank you for watching. Long live math. Happy 2025. Let's hope it doesn't turn out too terrible with Trump and with Project 2025 or any of that. But anyway, thank you for watching. Long live math. Happy holidays, and I'll see you guys next time.